So one approach is Hangman. A lot of us remember Hangman, where he drew it like this, and your goal was to figure out a word. And somebody would guess, H. Nope. So your goal was to try to answer it. So A, oh yeah, I have an A, so nothing on there. B, nope. Man, he's got a stick, and then you'd build up his legs. And the goal was to try to figure out what your word was before your person got hung. It's kind of a gruesome game, but the kids know that there's a point in which the game is going to end. So if we take that idea and we move it over to the partial products, I know I can take and make a hangman shape, and my students then totally get it. So we've played hangman for a little while, and their goal is to find the solution before they run out of space. The idea is you don't want to just let it go on and subtract 10 off each time. So here's an example. I'm going to do 3, 7, 5, oh. So my dividend is 3,750. And my goal is to try to solve this. So what I show my students is they divide off a section of the paper and call these fast facts. And this is the area in which I will do my estimation and my number work. And I want to keep it in a way that I don't have to come back and try to memorize it. So I show my students, I start with my powers of 10. So 1 times 15, 10 times 15, and 100 times 15. And we know that's 15. 10 times 15 is 150. And I can see that this is quite interesting. Now I had 1 times 15. I'm going to go to 2 times 15. 20 times 15, and 200 times 15. And we talk about everything as patterns. So 2 times 15 is 30. 20 times 15 would be 300. 200 times 15 is 3,000. I have something to start with. So I'm going to start, and where I make this one different from my students is when we take this 200 times 15 equals 300, and I make them go and act like they're going to grab that amount. I know there's 200 each, and that means we've handed out 3,000 pieces so far. I subtract off what I've handed out, and I have 750 when I don't make a silly mistake. I now have 750 pieces left, and I'm going to look here and say, maybe I can try. I know 3 times 15 is 45, so 30 times 15 would be 450. I have something I can work with. And this is where place value is going to become important, and we're going to need to think about how we're going to line this up. But 30 times 15, I can subtract off 450 pieces. 0 minus 0, 5 minus 5. I have 300 left, and my brain's going to go, oh, wait, look, I did that work previously. 20 times 15, each person got 20. And I subtract all 300, I have nothing left over. Now I have to add 200 plus 30, 230 plus 20 more, 250. So my solution is 250. And I line up my ones over my ones, tens over my tens, hundreds over my hundreds. And I can tell 15 times 250 is 3,750, or 3,750 divided by 15 got me this through the partial products method. The other way I've seen this done is where people line it up on their lined paper, and another approach is to use white lined paper to help students line up their place value. And here's the same problem done with the thousands, hundreds, tens, and ones place. And as they would have worked on each solution, so when we had 200, I'm going to know I have hundreds, tens, and ones. So if I had 200 times 15 was 3,000, I'm going to line this up. And what's nice about this is when I end up having my partial products, I know I can grab them and make sure I'm adding them up in the correct place value. So I would have had 0, 5, and 7. And when I went to the next one where we had already done the work and it was 30, I'm going to make sure my 30 lines up in the correct place value, my 1s and my 10s. And that's when we subtracted off 450. And then we went here and had 300. So when I subtracted off my 20, this is what I liked. And my 1s, that went, and that went. And then when I subtracted off my 300, and I had nothing less to subtract, when I added here, I would have had 0. Here's my 5 and 200. These columns allow me to keep the place value accurate. And this can be a really big. So let's look at where in the world does Pac-Man come in? Well, we know Pac-Man has a certain number of lives that exist. So I'm going to look, and I taught them to look at the dividend. If there's 4 digits, they get 4 Pac-Man lives, and trust me, they can all draw a Pac-Man, probably much better than mine. So, oh, that's a horrible Pac-Man. And here's my last Pac-Man. So they draw quick 4 Pac-Mans. That's how many lives they have. So this is, their goal is with a 4-digit dividend in only 4 calculations, can they solve for the quotient? So can they find the quotient or the other factor, this factor times that factor equaling 3,750? So here we go. I know I've got 4. So let's try this one again where we have our fast facts that they've written, always working with the powers of 10. And up on the side with a line so it doesn't end up mixing in. And I say 15 times what? Let's say I ended up trying this. Let's say I hadn't really experimented more. And I had said, fine, I'm going to say 15 times 100 was minus 1,500. I have used up 1 life. I'm going to solve 5 minus 0, 2, 3 minus 1, 2,250. Goodness. So let's say I tried that again. I said, all right, I'm just going to do 100. Here's life number 2. And I'm going to subtract off 1,500. Here we go. I have to regroup. 750. And let's say I try this one and I'm not using the best strategy. I'll try 20. And that's another life. And I subtract off 300. I have 450 left. And if I didn't look at this, and let's just pretend I tried that again and I went with another 20, I could solve it. But now I've used my last Pac-Man life. And while I can solve for 150, because I see that right here, it's taken me an extra life. So I wasn't very efficient. And my goal, like it is with Hangman, is to try to do this in less than 1, 2, 3, 4, 5 lives. I wanted to do it in 4. So I'm going to try to find a strategy that allows me to finish this in 4 lives. And the students completely understood this idea. They started really working with the numbers to see if they could solve it in 4. And then some of them started to look and say, could they solve it in 3 lives and have 1 leftover life? So they gave us a discussion about our partial products, as well as being able to have a discussion about strategies and why these fast facts really help. And one of the observations is they realized if they wrote it down, they didn't have to try to work from memory, and they didn't have to recalculate it a second time. The first time they had the answer here, they could use that in trying to solve and find the quotient. Let's go back to the next example. Here is our same dividend, 3,750 divided by 15. I have my 4 Pac-Mans, 1, 4 each digit. in the dividend. So we looked at this previous one in which the student did this in 1, 2, 3, 4, 5 lives. They used their fast facts. They did solve for it before they ran out of Pac-Man space, which is a nice visual that you're trying to close this out, but they used an extra life. So let's look at the next student strategy. They came back to this and they said, hey, I can solve this. I see if I look at 200 times 15 equaling 3,000, they have their 200 and they subtract off their 3,000 of the partial product, 1 life used. We get to 750. They realized they had this one. Subtract off 30. Here's my second life used up. Subtract off the 450. They had 300. They look back at their fast facts and they notice this fast fact. They say 20 times 15 takes off the 3,000. They have solved it in a mere 3 lives. They have a bonus life left over. This student really used fast facts and had to think through common sense. They had to think this out to see what they could find as the largest combination rather than subtracting off 5 times each time or 10 times each time and subtracting off the smaller possible quotients. So now they still have their 250. And I do like to show them we have hundreds, tens, and ones. So 250 is where we would put the quotient. And they solved that with 1 Pac-Man left. That's a pretty exciting moment for them.